So I'm going to walk you through how to use your graphing calculator to do a sample problem. This problem is from page 639 in your textbook, and it's problem number 40. And this problem involves a little jumping spider. So if you picture what's going on in this problem, we have a little spider who starts off at a particular height, and then he jumps up and he comes down. It tells us in the problem that we have an equation that's going to relate his height in millimeters, and we're going to track that using the variable y, which is why height in millimeters is along the y-axis, and the time since he jumped in seconds. And we're going to track that using the variable x, and so along the x-axis of my graph I have seconds. So at first he jumps up and he's going up, 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 but gravity is slowing him down and then eventually turning him around, and he comes all the way back down to the ground. The question asks, what is the maximum height that he reaches and how long does it take him to get there? Well, we can tell from looking at our graph that this point here is going to represent his maximum height, and that is the vertex of the parabola that is his jump. So if we know the y-coordinate of that point, that's going to tell us the maximum height that he reaches. And if we know the x-coordinate of that point, that's going to tell us how long it takes him to get there. So if I knew the coordinates of that point, I would know his maximum height and how long it takes him to get there. In the book, it tells us that there's an equation that relates his height with how long it's been since he jumped. And the equation is this: y equals negative 4,500 x squared plus 820x plus 43. So let me think for a minute about what I can tell from this equation. If I plug in a 0 for x, these two terms will both be 0. And so all I'd be left with on the right-hand side of the equation is 43. That means when x is 0, that's when no time has passed, so before he jumps, his height, y, is 43 inches off the ground. Sorry, 43 millimeters. So his starting height is 43 millimeters. So the peak of his jump is going to be somewhere higher than that. This is where we're going to let our graphing calculator help us. So the first thing that we need to do is that we're going to need to enter this equation in our graphing calculator. First, we're going to go to the y equals window where we enter equations in our graphing calculator. To get there, we push this button that says y equals on it. And now I need to enter this equation. I'm going to move this up so that you can see the keystrokes on this. Please be careful when you enter things. This negative sign out in front of the 4,500, you need to use the negative key down here, not the subtraction button. So we're going to enter negative 4,500 x squared plus 820x plus 43. So now we've entered the equation from our problem. And I'm going to hit graph and let's see what happens. And I'm expecting that I'll see a graph that looks something like this. That's not exactly what I expected to see. I noticed that my calculator did something, but it looks like all it did was draw a really solid line down the center of my graph. Well, what's going on here is that it turns out that our parabola is actually much skinnier and much taller than what I drew here. It's as though on our y-axis here, we're looking from 0 over to 1 second. Sorry, that's on our x-axis. We're looking from 0 to 1. And on our y-axis, we're looking from 0 up to, we're going to need to look even higher than this. I'm going to look up to 90 millimeters. And so I need to adjust my calculator's window to show me this view of the coordinate axis. To do that, I'm going to hit the button that says window here, and I'm going to change the x min to 0, and I'm going to change the x max to 1. And I'm going to change the y min to 0, and I'm going to change the y max all the way up to 90 because I want to be able to see quite high on this parabola. Now I hit graph again. Okay, that graph looks a little bit more like what I expected. So I've been able to zoom in on the little spider's jump there. Now what I need to do is to find the coordinates of that point right there on the parabola, the vertex. The calculator can help us do this. It's a calculation that we're asking it to do, and so we're going to use the second button to access the things that are shown in blue, and then click on the button that says calc in blue over it. Second, and then calc. And it shows us the calculate menu. One of the options, option number 4, is the maximum. We're looking for the maximum value of this function. That's going to be the vertex of our parabola, and we want the calculator to help us find that. So we're going to select option 4. The first thing the calculator says is left bound. We need to specify where we want the calculator to look for the maximum value. We want it to look between about here and here on our graph. So I need to specify that in the calculator. So I'm going to use the little arrows, and I can see the x and y coordinates here. And what I'm looking to see is when does a little bitty arrow show up, tracing along, there it is. So there's a little blinking, it's actually a little blinking X. And at first I need to place that to the left side of the vertex because I need to say start looking here. So I'll place it to the left of the vertex and hit enter. And then I'm going to use the right hand arrow and I'm going to move that little dot past the vertex. Now notice the calculator says right bound. I'm going to hit enter. So I've told the calculator look in between these 2 points here to find me the maximum value. The calculator is asking, do I want to input a guess of that point or do I want the calculator to do the work? I don't want to input a guess, so I'm just going to hit enter and the calculator is going to do the work for me. And it finds that point and it labels this as a maximum with an x value of 0.0911. And it tells us it has a y value of 80.356. So it's given us the coordinates of the vertex of our parabola. So our calculator helped us find the coordinates of this point. Now we need to make sense of them though. So the y coordinate of the vertex was 80.36. Remember that in this problem, y stood for the height in millimeters. So the highest point that the spider reached was 80.36 millimeters. The x-coordinate of the vertex is 0.0911. Remember that in this problem, x stood for the time in seconds since he jumped. So he was at the very highest point of his jump, 0.0911 seconds after he jumped.